Hey guys, hope you're doing well. Today's video lesson is going to be on probability, more specifically geometric probability. Probability itself is a ratio of what I like to call what you want and versus what you can possibly have. They call it a sample space. So let's go ahead and take a look at the notes that you guys hopefully have, and then we'll take a look at some examples for how we're going to use this for probability. So let's turn on the background here. Let's shrink us up into the corner, and then let's go over here. All right. So if we come over here and we're looking at probability, basic probability is a ratio or a fraction, and I refer to it as the number of what you want versus the number of possible in that sample space. Very common probability questions have to do with the rolling of a die. So there are 6 sides to a die. So the number of possible would be 6. And then the what you want depends on what the question is. So if I say, what is the probability of rolling a 3? Well, there's 1 3, and there's 6 total possible, so the probability would be 1/6. What if I ask for the probability of rolling an even number? Well, you've got 2, 4, and 6. So there's 3 of what you want over 6 total, and you're going to have a probability then of 3 over 6, which reduces to 1/2. All right. Geometric probability, though, this is based on geometric measures, and this is a measure of what you want versus what is possible. And so this could all be based on shapes. It could be based on circles. It could be based on line segments. There's any number of things that we could use for the what I want versus the what is there. Now, I included in your notes some examples of various geometric probabilities. So you've got the length. So you've got the entire line segment AD. That's the sample space. That's the what you want. The event, the what I'm looking for, could be BC, this little section here. So then the fraction would be BC over AD. For a circle, angle measurements. Well, an entire circle is going to be 360 degrees. So the what I want is this blue portion, and that's just a small little region. And then let's say I'm talking about area. Well, the sample space, the entire thing that is possible, is the rectangle. The event, the what I want, is the triangle inside of it. So that I have the ratio of the triangle over the rectangle. Okay, so again, the ratio or the fraction of what I want over the total sample space. So let's take a look at some examples for your homework page. So over here we have 10-6 practice A, and we'll work our way through certain portions of this. If I look at the first portion here, I have a line segment with 8 and 4 and 6. So that makes the whole entire thing a total of 18. So if I want to say, okay, there's a point that is randomly chosen somewhere on this line segment, and it wants to know the probability that that random point is on QR. So QR is right here. So the probability is going to be QR, which is the what I want, over the total, which is PS. Well, QR is this little portion here, so that's 4. PS is all of it, and we found that to be 18. So the probability that some random point is in this region of QR is going to be 4 over 18, which reduces to 2/9. All right. Well, what if that point is randomly on PQ? So it's going to be PQ, and PQ is going to be over the whole thing, which is PS. PQ is 8 over 18, and so the probability then is 4/9. Okay. So we break that down into each section. So let's take a look. What is the probability that the point is on RS? Well, RS, the what I want, is 6 over the total, which is 18. And I'm always going to reduce down my fractions if possible. So that's going to be 1/3. The probability that it is not RS. So it's not this one. That means it can be the other two. So if it can be the other two, that's going to be 8 and 4. That's 12 out of 18 possible, which is going to then reduce down to 2/3. So again, what do I want versus what is possible? So let's take a look at the next section here. The signal at a crosswalk has the following cycle. Walk for 10 seconds, clear the intersection for 10 seconds, and don't walk for 20 seconds. And this line segment represents that situation. So find the probability that the signal will show don't walk when you arrive at the intersection. Well, what do I want? I want the don't walk section, so that's 20, out of the total, and the total possible, there's a total of 40 seconds in the cycle, so I've got a 20 out of 40, which is going to be 1/2. You walk this way every day. Find the number of times the signal will show walk out of 20 times that you arrive. Hint, find the probability and multiply that by the number of times that you arrive. So if I look at this here, and I want to say, okay, you walk to this every day, find the number of times the signal will show walk out of 20 times that you arrive. Well, what is the probability, first of all, that it's going to be walk? Well, walk is 10 out of 40 seconds. So that is 1/4. So 1/4 of the time, it's going to say walk. Well, if I'm going to take this 1/4 and I say that I have a total of 20 times that I show up, I'm going to take 1/4 times the 20 times that I'm there. Because 1/4 of the time, in theory, it's going to say walk. That means that there's going to be a total of 5 times that I show up that it's going to say walk. Let's move on to our circle spinner here. Remember, an entire circle is 360 degrees. And I've got my spinner, so it's like we're playing a game, and I spin the spinner, and it goes around and around and around and around and around. And it wants to know what is the probability that the pointer lands on region D. Well, if I look at region D is 60 degrees. So it's 60 out of 360 because an entire circle is 360. So the probability that it lands there is 60 out of 360, or 1/6. What about the probability that the pointer lands on B or C? Well, B or C is going to be 30 and 90. I have the option for both of those. So this one's going to be 120 over the 360 total. So I'm going to take both of these and combine them. And 120 degrees out of a 360 total is going to reduce down to 1/3. Okay. And if I've got the region landing in A, that's going to be 180 out of 360 because A is 180. And then the second one here is, what if it does not land in A? Well, if A makes up 180, not region A is the rest of it, which is also, in this case, 180. So both of those are reduced down to 1/2. And let's take a look at the last section here. Some probability using the area. Find the probability that a point chosen at random inside the rectangle is in each given shape. And then round to the nearest hundredth based on what we've got there. And so it's like I would toss something. It's like a table. And I'm going to toss something on the table, and I want to know the probability that it lands in a certain area. Well, what is the total possible that I have? The possible is the entire rectangle. So I'm going to take that entire rectangle, and that entire rectangle is going to be 5 times 7, or 35. The area of the whole entire rectangle is going to be 35. So find the probability that the piece I'm looking for lands in the triangle. Well, let's find the area of the triangle. The area of the triangle is base times height over 2. So the base is 3 and the height is 4. So the area of the triangle is 12 over 2, or 6. And while I'm at it, let's find the area of this square. 2 times 2 is 4. So the probability that this lands in the triangle is going to be, what I want is 6 over the total possible, which is 35. And it says round that to the nearest hundredth. Well, what I'm going to do is I'm going to go ahead and put 6 over 35 in the calculator, and I get this decimal. And to the nearest hundredth, I'm going to be looking here at 2 decimal places. So I have 0.17 for the probability that it lands in the triangle. Well, the probability that it lands in the square, what I want is 4 over 35 total. So 4 over 35. And 4 over 35 is going to be 0.11. So I have a probability of 4/35, or approximately 0.11. Well, the probability that it lands in the triangle or the square. Well, I want both of those, so that's going to be 10 over 35. And 10 divided by 35 is 0.285, which will round up to approximately 0.29. And then finally, not the triangle. Okay, not the triangle would be everything else. So I am going to take the entire thing, which is 35, and I am going to take away the triangle, which is 6. So 35, take away the triangle, is going to leave me with 29 over 35, which as a decimal rounds to 0.83. So again, let's recall that probability is what I want over what is possible. So for each problem, I have to consider what it is that I'm looking for, and then what is the possible outcome in that sample when I do it. So this is a brief lesson on probability, and then using that probability with geometric probability. Your homework is to do 10-6 practice B, and if you've got questions, remember, bring those questions to our Zoom session on Thursday. Have a great day. See ya.